Good morning. Welcome, digital pathology trailblazers.
Learn about the newest digital pathology trends in science and industry. Meet the most interesting people in the niche and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
We are going to start with paper number 1, which is Artificial Intelligence-Based Digital Image Analysis for Assessment of Ki-67, P53, PHH3 Expression in Glioblastoma Multiforme. And I did prepare for you what these markers are for. So the Ki-67 is proliferation index, P53 tumor suppressor status, and PHH3 mitotic marker. Ki-67 is for proliferation during the whole cell cycle, and PHH3 is specific for whichever phase of mitosis. I think it was G2. But let's look at this publication from Turkey. And the objective here was, I don't like this blue color, maybe orange, let's do orange, to compare AI-based image analysis for Ki-67, PHH3, and P53 IHC biomarkers in glioblastoma multiforme with conventional evaluation performed by experienced pathologists. So not too complicated study design. And we've seen that, last year, a lot of these image analysis algorithms being evaluated, unimodal classical image analysis, but people going digital and taking this first step of using some of these markers, right? So that's what they do here. Specifically, what they did was a cross-sectional analytical study. It's a study design that evaluates this variable and the outcomes at the same time. And they had 20 cases of glioblastoma, and they used our stainees, Ki-67, PHH3, and P53. And they digitized the slides, and 2 expert pathologists and AI-based image analysis was used. And they use different areas, 1 square millimeter and 7 square millimeters of tumors. And the results, the interesting thing was, intra-method comparison showed strong consistency, both AI and pathologist assessment at 1 millimeters and 7. So strong consistency for both AI and pathologists. But in AI analysis, there are significant correlations between Ki-67 and PHH3, which we would expect, right? Ki-67 is proliferation for the whole cycle, and PHH3 is mitotic figures. So there should be a correlation, right? The more cells are proliferating, the more mitotic figures we will have. And also, we had between PHH3 and P53. So P53 is the tumor suppressor. And if there's no tumor suppressor, there's going to be more proliferation. So less tumor suppressor, more proliferation, more mitotic figures. But no correlation was observed between these markers at either field in pathologist assessment, which tells me let's do AI, because there should be a correlation. There is some kind of loss of precision maybe when we are doing it manually. And you already know my opinion on counting cells manually. It's not a favorable one. I don't support that. I think computers should count dots in images. So that's what they did. I was about to do this one, assessing the influence of 2 deep learning assistance modes on pathologists and cancer identification, but there was no abstract available here. So I need to skip this one. So we're going to move to the next one, the Digital Lab Practical Digital Workflow and Integration of AI for Routine in Pathology through the example of prostate cancer. So I like these papers because they show real life struggles of people who did it, who went digital, and now I think that digital pathology is not that niche anymore, even though in the medical, in general in medicine, it's probably niche. But in pathology, everybody has heard about digital pathology. People know what scanners are, right? So now the shift that I'm seeing at conferences and in these papers, that people actually talk about their failures, which is fantastic, because then you can read this paper and avoid the failure. Is that not fantastic? I think it's beautiful because there's no such thing as journal of negative results. And I struggled with this during my PhD when I had like negative results and I was required to publish it. Nobody wanted to take my publication. In the end, I did publish it somewhere. So there is a record of my PhD thesis. But here we are incorporating our failures into the story of our success, right? Because there is no success without failures. You just have to get up and keep going until you succeed. And that's what they did here in France. This is a French publication. And let's talk about their successes and about their struggles. So this is Rennes University Hospital. Digital pathology has been routinely deployed since 2020. Like, kudos for that. Here, a heart for them. Since 2020, that was COVID. You are amazing. And then AI solution for prostate adenocarcinoma by IBEX. Also, shout out to IBEX that they provided it. That was since July 2023. So now we are in 2026. They've been using it for almost around, not yet 3 years, right? In July, it's going to be 3 years. And they talk about their experience. They assess the impact of digitization on the various professions within the department and prospective use of AI for routine diagnosis. So obviously they did validation and calculated their concordances and everything. So concordance between AI and pathologists was 93.2 for detection of high probability cancer, 99 for low probability slides, and then there's some intermediate probability, and their cancer was confirmed in 4.7 cases. Gleason grading concordance rate was 76.6, and the integration of AI has not changed the use of immunohistochemistry. So that's interesting. They still use the same amount of immunohistochemistry. And then there was a 10% failure rate related to pre-analytical artifacts. I think now in the era of fancy algorithms and foundation models and us like pushing the frontier of computational and digital pathology, sometimes we forget about pre-analytical artifacts unless you are a researcher that works on the TCGA dataset and you have a dataset full of artifacts and also frozen section images. So there you probably remember, but here like 10% failure rate due to pre-analytical artifacts that can be avoided, right? So they say that effectiveness of digital pathology and use of AI models, specifically, I would say, that's my words, are closely dependent on pre-analytical quality and its organizational integration. And actually, recently I gave a webinar about the importance of pre-analytics. So I will link it in the recording here so you can check out how important they are. Oh, now we have a heavy one. I was reading to this one. It's multimodal learning for scalable representation of high-dimensional medical data. So I'm like, what does this even mean? I'm going to explain you what it means. And then I go through this abstract, and then I see who is one of the authors, Hamid Tizzouche, and the first, he's the last author, and the first author is Arij Al-Safin. I hope I pronounced the name correctly. And this is Chemia Lab, Mayo Clinic, and also, Mayo Clinic. Hamid's research is very computationally heavy and very clinically useful. That is like a focus of his, is it has to be clinically useful. And it sure is computationally heavy and, well, not computationally heavy, let's say deep computer science, let me call it that way. Deep computer science for pathology to be useful in pathology. So let's look at what they did. So integrating AI with healthcare data is rapidly transforming medical diagnostics and driving progress toward precision medicine. We agree with that. We talk about it every week. But multimodality, effectively leveraging multimodal data, is not that easy, particularly digital pathology whole slide images, because they're big images. So obviously from the computation standpoint, they're difficult, and genomic sequencing remains a significant challenge. Also because these are two different categories of data, image data, and it could be, I don't know, just like text data or tabular data, genetic sequencing. So these are like two different types of data. So they have this intrinsic heterogeneity. These modalities have the intrinsic heterogeneity. And there is a need for scalable and interpretable frameworks. And existing models are unimodal data, right? It's usually what we just saw, something on pathology images only, something on genomics only. There are combinations, but it is not the norm yet. So they introduced MARBIX, also known as Multimodal Association and Retrieval with Binary Latent Indexed Matrix. Yes, very creative and sounds like computational pathology very much. So, but this is a self-supervised framework that learns to embed whole slide images and immunogenomic profiles into compact, scalable binary codes termed monogram. So they have this model, do embeddings on whole slide images, and then do embeddings on genomic data, and they combine them together to basically group together similar cases. But similar cases not only in terms of, okay, what was the histopathological morphology or what was the genomics, but the combination. We have the multimodality. And here they optimized a triplet contrastive objective across modalities. So what this is, you have like a base case, then you have a similar case, and you have a dissimilar case. So you have three cases. That's the US way of showing three. This is the Polish way of showing three. So you have three cases, right? The case that you look for similar cases to, a similar case and a dissimilar case. And this is this triplet contrastive objective for both modalities. And they captured high resolution patient similarity in a unified latent space. Latent space is like what a model learns, not what we would see. So it learns something in both whole slide image, genomics, and then they create space, this unified space, which is a space together. And then we have this code telling us, okay, this is a similar case to another case. And you can search by similarity. And this enables efficient retrieval of clinically relevant cases and facilitating case-based reasoning. So you basically you don't have to do, show me similar whole slide images and then go again and show me show me similar genomic. You can have this one vector grouping them together. And then in lung cancer, this MARBIX achieves 85 to 89% across all evaluation metrics, outperforming histopathology and immunogenomics. So we have a better thing than just each one of these, right? So the histopathology is 69 to 71, and immunogenomics 73 to 76, and the MARBIX is 85 to 89. And then they also did in kidney, there's real value monograms and the binary monograms. So real value is like continuous values, not just 0 ones, and the binary is a simplified version of these monograms, these codes, that is just 0 1. And the F1 for the real value is 80-83, accuracy 87 to 90, and for binary is slightly lower, 78 to 82 F1. Binary is easier to retrieve, less data heavy, and the real value is a little bit more slow to retrieve. I don't know the magnitude of change, but basically they're good. They're over 80%, and we have multimodality that could be clinically useful. So I definitely want to dive deeper into this one. So I'm going to be creating an abstract. Also, to explain in a non-computer science language what they did and why it's useful, because I already know it's useful. And we have a cool one. I should have said at the beginning that we have a super cool one at the end, which is about patients. Here. Patient impression of the digitization in pathology and AI, which is so important, but so under discussed. And it's going to be discussed more in the podcast. I'm going to have patient advocates, and we already had a few patient-centric pathologists. We had Dr. Lydia Joseph, we had Dr. Marilyn Bui. And so if you want to go to these podcast episodes, I will link them in the show notes as relevant episodes. And for the recording, we can also put them in the cards. But the connection between patient and pathologist, I don't think it's an overstatement, is almost non-existent. Pathologist is kind of invisible to the patient, and it's not about the pathologist as the person that needs to be visible as a profession, which also is an important thing, but the insights and the information that the pathologist brings to the treatment continuum. This is basically the diagnosis, the image, the report is what the treatment is based on, right? So now we're using digital tools, computational pathology, AI. What do patients think about it? And this is a publication. This was a roundtable held in Belgium with patient advocates. It was a digital pathology and AI. So digital pathology and AI promise faster, more accurate cancer diagnostic. Yet patient views remain undocumented. And so they documented, and I'm super happy because this is something I want to dive deep into as well. So they had a 2-hour moderated roundtable with 6 Flemish cancer patient advocates. It was recorded, transcribed, and analyzed using reflexive thematic analysis. And patients anticipated improved accuracy, shorter turnaround times, and stronger inter-laboratory collaboration. Good thing is trust in AI was high when, that's important, algorithms were trained on diverse data sets and pathologists retained final responsibility. So here, 2 aspects here: diverse data sets, not just, one population, one hospital, one group of patients, and pathologists in the loop. So they trust the pathologist, and then by proxy, if the pathologist trusts AI, and that should be the case because it should be validated correctly, right? And then the pathologist should have trust and the final say, then patients are okay with this. And there are a couple of other very interesting insights. So clinical validity outweighed full algorithmic transparency. So meaning they care a lot less about knowing what's inside the algorithm if it's clinically valid. And then, but they do encourage explainability research. Then also explicit mention of AI in reports was considered unnecessary if quality assurance was demonstrable. So that's interesting as well. I think there is a requirement. What does GDPR say about it, or our European AI regulations? I think whenever AI is used, it needs to be mentioned, but patients said you don't have to explicitly mention it if there is enough quality assurance, right? This is good. This is very positive sentiment to me because it signals there's no fear. It is rather considered as another diagnostic tool. And if you validate it, if you have quality assurance, then we're fine doctors using it. We still trust the doctor. If this is the tool they want to use, let them use it, right? That's patient advocates in Belgium. Privacy worries focus on potential insurer misuse rather than pseudonymized cloud transfer. So what I'm seeing is here, okay, what are the things relevant for the patients, for the particular patient as a person? More worrying is insurer misuse of the data than pseudonymized cloud transfer, right? So very tangible, very personal, very, okay, what does this mean for me as a patient when AI is used or not used, and the dangers of AI, which is kind of a little bit different voice from what you hear in the industry. And the representative requested future tools that translate technical reports into lay language. And we have some of these tools already. There are websites like that. I'll try to find them for you. Or if you know which one these are, put it in the comment, even if you're watching the recording, because that's going to be useful. But I'm going to find that as well. But there are some of these. Maybe European people don't know about them yet, so I need to talk about them more. And then suggested questions to support shared decision making. So I want to see what questions they supported. But another heart here, because patients' representatives were generally supportive of the introduction of AI in pathology, provided the algorithms are clinically validated, trained on representative data sets, and deployed under clear professional oversight. We need to make a quote out of this because it signals a positive sentiment towards AI, where you still have this fear. You still have there's still cases where when AI is mentioned, people are so afraid that they withdraw from clinical trials, which is so sad, because it's already so difficult to get into one, right? But here they express positive sentiments. And there's expectations regarding human AI collaboration, data governance, auditability, and communication about AI use. I love the keywords: AI, digital pathology, patients. So that's what patients say about AI. And I'm so happy that this is published, because how are you going to get to this type of insights. And I don't think I have anything else for today. Get the book, because then you're in the newsletter. Getting the book for free, the PDF, is gonna get you on the newsletter, and then you're gonna have information. You're gonna get a lot of emails from me, so prepare for that. And you are free to choose which you read and which you don't read. But the book is free. The PDF, this paper version, is available on Amazon, so you can just Google it, or I can send you the link as well. I should do that. So get the book. You're going to know everything. If you're interested in checking out these AI-generated paper summaries to go a little deeper, it does not replace reading the paper, okay? Let's be transparent here. It's not that, AI is going to tell you about all these things, but it definitely goes a little deeper than just the abstracts that we're doing during DigiPath Digest. This is something that's useful for me, so I assume it's going to be useful for you. You can check it out. There's already one in there. All the ones that I'm doing today are going to be in there as well. And with that, I wish you a fantastic day. If you have any questions that you have not asked yet, or if you're watching the recording, listening to the recording, let me know in the comments. If you're interested in my second book about how to get access to digital pathology images, I'm going to be opening it for pre-sale soon. So if that's of interest to you, let me know in the comments, and I talk to you in the next episode.